AI promises big benefits for your business. But is your data center and your IT team ready for the AI revolution? Juniper's AI Data Center solution is the quickest and easiest way to deliver high-performing, scalable networks for AI training and inference. We take an operations-first approach, which provides simple and seamless experiences that save time and money without vendor lock-in. And Marvis, our virtual network assistant, makes it easy to see and fix problems quickly. Juniper's open AI-optimized Ethernet solution ensures feature velocity and cost savings. Leveraging a vast Ethernet ecosystem pushes down costs, assures faster innovation, maximizes design flexibility, and avoids vendor lock-in. Finally, Juniper delivers end-to-end secure solutions that enable you to build high-performing AI data centers with flexibility and ease. We make every connection count.
Welcome. Today, I want to welcome you to our Launch of the Seas, the AI Moments. We all see a big market opportunity ahead of us because AI will be bigger than the internet is today. So when you consider every government, hospital, automotive, manufacturing company, and many more will use some kind of AI infrastructure in future, our customers need to invest a lot into infrastructure. Many global analysts report that investment in networking infrastructure will expand dramatically. Most of our customers started with some use cases of AI within the public cloud. After getting more professional and on AI, they're adding more and more use cases. They are moving onto on-prem AI cluster because it's cheaper and safer. And this is true for inference and training cluster at the same way. And here is where Juniper Network fits the best. Today, we want to show you our open and vendor-neutral AI data center approach. Different vendors from chip over GPU to storage will participate and give you a different insight. Within the next 12 months, you will see a big competition between different vendors because every use case is different. For example, specific GPUs for a unique use case. We have customer testimonials across many segments and verticals for you to validate our achievements today. And these are all built on Ethernet, not InfiniBand. In our Open Labs for AI, we showed prospects and customers already Ethernet is the better choice. Costs are down, delivery is quicker, open standards are helping to integrate different vendors, and completion time for the workloads is the same or even better. Especially because the network is only roughly 6 to 8% of your investment of an AI cluster, this needs to work exactly as expected. Our powerful AI ops solution, Marvis, integrated with our lifecycle and automation solution, Apstra, are helping our customers across all verticals to operate smarter, quicker, and more reliable. On our event on September 10th, we just showed how easy our customers can leverage all advantages of AIOps within all DC solutions. You should have a look into this. When you want to meet my global team to get more details or discussions about your requirements, just reach out to Eric Van Hent for Europe or Dave Watkins for emerging markets and APAC. Our team is there every day to support you to build the best AI cluster you can get for your use case. And with that, thank you for your attendance today, and over to you, Rami.
We're so glad you're here to join us for an exciting lineup of speakers on the future of networking for the data center. You know this, we're living in the era of AI, and it is transforming all aspects of your technology and your business. For technologists like me, it feels like we're seeing the future unfold before our eyes, and it's incredibly exciting. The pace of advancement and growth in the three critical ingredients of AI is simply breathtaking. We're seeing massive scale in AI models, in the data that's being used to train AI, and in the computing infrastructure that makes it all possible. Which means your AI data center infrastructure is growing at an unprecedented rate. Dell'Oro Group estimates that AI application traffic is growing by a factor of 10 and AI cluster size by 4 times every 2 years. There is rapid innovation at every layer of the stack, and you're faced with keeping up with that incredible pace of change, all while managing the immense power needs of AI. Nonprofit energy research organization EPRI says in a new study this year that AI queries require approximately 10 times the electricity of traditional internet searches. And generation of original music, photos, and videos obviously requires far more. With these intense energy requirements, data centers could consume up to 9% of US electricity generation by 2030, more than double the amount currently used. Clearly, you need a partner who knows what they're doing to help you on your AI journey. And Juniper is that partner. We're not new to AI. When it comes to understanding the awesome power of AI in solving the pressing IT problems of today, nobody has more experience than we do. We built the industry's most comprehensive AI-native networking platform that's transformed the experience of networking for both end users and operators. With our AI-native insights and automated actions, the Gap reduced their site visits by 85%, and Dartmouth College reduced their time to deploy infrastructure by a factor of 9. As proof of our market traction, look no further than the success of our campus and branch business. Mistified revenue, including all products driven by Mist AI, grew nearly 70% in 2023. That success does not come by accident. So again, we understand the awesome potential of AI simply because we've been tapping into it for years and seeing great success as a result. But this event is about the stuff that makes AI possible to begin with, the infrastructure stack that makes it all a reality. It's what we call networking for AI, and this is an area where we've been investing heavily and seeing some real momentum. In fact, we're the first branded networking vendor to launch an 800 gig E-switch based on the Broadcom Tomahawk 5 chip. Our new PTX 10002 leverages our own Express 5 silicon to achieve industry-leading performance and power efficiency for the AI data center spine and interconnect. And we've built innovative new congestion management features for AI into the industry's most advanced data center fabric management and automation solution, Apstra. Through our own testing in our Ops AI lab, we've demonstrated that Ethernet performance is on par with InfiniBand for tough AI training use cases, and we've shown that Ethernet is far more economical. It is no wonder that our AI data center customer wins are ramping up rapidly. The University of Wyoming, Deutsche Bahn, and AI supercomputing company Cerebras have all signed on, just to name a few. We're also working with social media companies and AI as a service companies, which need the tremendous networking and compute power that large language models require. AI has the potential of being as big, if not much bigger, than the internet. The market opportunity is immense. To win, we can't just make incremental moves. We all must take bold actions. We believe that for AI cluster infrastructure to move from early adopter stage to mass market, the industry must coalesce around open technologies to harness the collective power and innovation of an ecosystem. And this is why we're here today. With Juniper, you can make every connection count. Thank you for joining us.
All right, thanks, Rami. Great to hear about the growth, especially in campus and branch, and the opportunities for Juniper's customers and partners that bring value to the AI data centers. This is a new big thing. This is huge, Bob. This is absolutely the next best thing.
Yeah, absolutely. I mean, Juniper's done a great job of driving innovation and extensible technologies into the campus and branch, and now they're shifting that into the AI data center. So great opportunity for them going forward.
All right, we got more. Next up, Juniper's COO, Manoj Linanavas, hosts the president of Broadcom, Charlie Kawwas, in an exclusive fireside chat to talk about the AI market trends, customer use cases, and needs. Here it is.
Charlie, thank you so much for joining us. Can you tell us a little bit about yourself?
Well, Manoj, first of all, thank you for having me here. It's an honor and a pleasure. I've been at Broadcom for about 20 years, but in the last few years prior to this job, I was the Chief Operating Officer at Broadcom, and specifically during the COVID days, which was a lot of fun.
First off, if you think about Juniper and Broadcom, we've been partners for well over 20 years. It started off with Juniper custom ASIC design, where we partnered closely with Avago, which is now Broadcom, and then a plethora of our systems, whether it's routing systems, whether it's Ethernet switching systems, wireless, and even security systems have been based on Broadcom chipsets. And most recently, we're also collaborating on SerDes and optical technologies. So there's a lot of rich partnership heritage there. Thank you for that partnership.
Well, thank you for that partnership. And as I said, I've been at Broadcom for 20 years. So for that entire journey that I've had, we've interacted on almost every technology we have, including, believe it or not, on LEDs.
That is very true, very true. But today, we're going to talk about AI market trends. When we talk about AI, especially Gen AI, has taken the world by storm in many ways. Whether it's ChatGPT, or whether it's Gemini, whether it's Claude or Llama, these are all household names now, right? So the world is changing so fast. And if you look at the people behind this, it first started off with the hyperscalers, naturally, but now enterprises of all shapes and sizes, AI companies of all shapes and sizes, and even sovereign nations are building large AI clusters, right? There's an amazing amount of that going on. This is going to be bigger than the internet. What do you think?
Well, I have to tell you, we're very lucky to be in these positions during this period. I can't agree more with you. I think our journey in AI actually has started in the last, I would say, decade. Collaborating with some of the hyperscalers who, you're right, are the bulk of the market today. And because of them, we see this growth, and it is becoming a huge inflection point, I think, not just for us in tech, but you're right, I think this is going to be used in so many other applications, medical, public sector, all kinds of applications we'll see beyond even video generations and imaging. And so as a result, I think the technologies we're working on are going to be critical, especially the stuff we're collaborating on. But to be specific, if I look at the hyperscalers, last year they spent, I think, close to just the top 4 in the US, $145 billion on their total CapEx, which includes AI. Just in the last 90 days, in their earnings calls, they've announced that they're increasing that number to over $200 billion because of AI. So that almost $60 billion incremental spend with only 4 companies, just to imagine the amount of technology and obviously innovation that's going to drive. And to your point, we're seeing a huge waterfall into the enterprise, which is the next opportunity, I think, for both of us that we're excited about. So I'm excited to see what you're planning to do in this space as well.
From our perspective, I think AI is not new to us. If you look at the Mist acquisition, which happened about 6 years ago, we are early adopters of AI. In fact, we are the first networking company which brought AI ops to networking, so that we have a pretty much self-driving network in the enterprise campus right now. Again, it's possible because of the Marvis AI engine. So much so that Gartner has validated it in Magic Quadrants, and my belief is that Juniper is writing the playbook for AI for networking, and no other company comes even close. But today the conversation is not about AI for networking, but networking for AI. All the buzzes about that, right? All the industry buzzes about Gen AI and these large-scale models and training and all that stuff. So on this front, we've been engaged with hyperscalers. We've been getting great traction there. We engaged with enterprises. And when I say enterprises, it's not just the large enterprises. Small enterprises, mid-sized enterprises, everybody's interested in this across multiple verticals, whether it's pharma, whether it's retail, whether it's finance. And let me just make it real with a few use cases. That's probably the best, right? One large cloud provider who we're working with, they want to train a very large-scale model with our gear, and our gear based on our systems with your chips, and we'll talk more about that later.
Yes, thank you.
Second, a large enterprise, a retailer, they want to do AI for e-commerce. They started off with public cloud, but they quickly decided, okay, they want to build it on-prem. They want to have an AI cluster for both training as well as inference. So they're also using our gear. A large financial in Wall Street, in New York, they have thousands of GPUs in the harness, doing complex financial analysis. And they actually came to our AI lab here. They tested their ML stuff with our benchmark lab, and they were happy with it, like how Ethernet fabric performed with that. And Ethernet, open systems, what is your perspective on that compared to some of the closed systems we are seeing today?
I think you said the magic word, which is Ethernet. It actually built out the internet for us, built out the campus, built out now what we know as the AI infrastructure. Both of us are contributing to this with the whole industry to continue to evolve Ethernet and keep it open. Ability to scale it, which is actually what we both are doing, and you referred to some of the wins we both have, and we're very happy and proud to be providing that technology to you and to the hyperscaler.
Talking about power, so a recent article in The Economist, stated the International Energy Agency, IEA, talking about the demand by these power-hungry AI clusters as well as cryptocurrencies. Both of them, demand which is putting on the grid. The expectation is that in 2026, almost 800 terawatt hours is going to be the requirement by just these use cases. And our grid is not there, which is why power efficiency is actually vital in this whole equation. What is your perspective on that?
I totally agree with respect to the power, and actually the power starts with semiconductors, to tell you the truth, and from there it grows into the systems that you build and provide, and then the data centers that our customers, whether they're the enterprise guys or hyperscalers, do. But I brought one toy with me that I actually would like to show you, and I know you know this very well. So this is actually the fastest Ethernet chip in the world. It went to production last year from a silicon point of view. And it was the first chip that actually can do, in 5 nanometer, 51 terabit per second. And the black thing that you see in here is the die. And as you can see, it's a single die. This is the only chip in the world that actually can deliver 51 terabit per second with a single die. Every other solution that came afterwards, late to market, has to use multiple dies. So as a result of that, the first advantage is 5 nanometer, low power. Second advantage, single die versus multiple dice, low power. And then the ability to actually do all of this in a single system with the power efficiency that Juniper brings to the table. And I believe, I'm going to pass it to you, I believe you have been shipping this product to the market, which we're both very proud of. And it actually sets a new benchmark in terms of delivering the lowest power network for AI infrastructure.
Well said, Charlie. I think we are absolutely proud to collaborate with you on this, and I'm also proud to say that we delivered the industry's first 800 gig system based on this Tomahawk 5 chipset. I'm very excited. The customer feedback has been flawless, has been great. It's an exciting time for us, which actually segues into, what's next for us, right? What's our vision? What are the solutions we're bringing to the market from both companies' perspective? And maybe it's a good time to kind of talk a little bit about that.
I think there's also capabilities that we can drive lower power as we both innovate together at the system level with optics capability. And I think if you think about the heritage of Juniper, where Juniper started as a company, and if you think of the heritage of Broadcom going back to the Avago days, actually Avago comes from HP Microelectronics, which invented actually the laser. So we have a lot of capabilities between us that could set a new benchmark in power reduction and efficiency. And I'd love to hear from you a little bit more before I tell you a bit more about what we're doing. I'd love to hear as well a bit more about what Juniper is planning to do in this space as well.
Thank you, Charlie. First off, proud to have this and industry's first 800 gig full system for AI clusters. And our own custom silicon, which does debuffer, is also used for 800 gig backbone applications. Now people are building AI backbones, not just the traditional WAN backbones. So you're proud to say both of them are there. But it's not just that. We have our system, intent-based system for heterogeneous operations management, as well as automation and closed loop avoidance. So that is actually our Apstra system, which actually makes sure that from an end-to-end perspective, from a NIC to the network to the workload perspective, we can actually manage things properly, even in a heterogeneous environment. And what I told earlier about Mist, we're taking the Mist technology and the Marvis AI engine and expanding it to the data center to provide data center assurance. How does the data center become self-healing? So there's a lot of cool innovations we're bringing together. But I'm also equally proud to say that both of us believe in that open ecosystem world, open standards, open ecosystem. Right from the founding of the company, Juniper always believed in the open IP networking ecosystem. Yeah. And we continue the same thing, ecosystems, standards, industry consortiums. We are working together, and I think I'm proud to work with you in an open fashion there. For instance, most recently, ML Commons, another open Ethernet open consortium, have come out with, how do all these companies compare? How do benchmark? Why does a particular networking system work with a particular model better than the other? We need to have some common industry benchmarks to do that. So we worked with ML Commons to do that. In fact, we are the first company who did a multi-node Llama-based model for inference in the ML Commons harness. So we're excited to do that. And the last step is power. What's the fundamental new thing we can do about power? And I know you have some secret sauce up here.
Yes.
More than this chip,
yes.
There's something coming. So I would love you to talk.
Yes. So first of all, congratulations on all of these achievements. I have to say, we are very proud at Broadcom to play a small part in the big innovation that Juniper brings to the market. By the way, we love Mist. We saw, and we have been collaborating on Mist for many years. We continue to see the success, including the AI capabilities you have, so very proud of that. But to go back to the power element, as we look at the networks that are built, a lot of the power stems from optics. So one of the things we thought about is, how do we go drive power significantly lower, for example, in 51 terabit per second systems, and going beyond that in the future? And that's the second toy that I want to show you. So I know this looks like the size of my hand, but it actually is pretty cool stuff. So the black die that you see in the middle is the same one that you see there. That is the Tomahawk 5 die or chip. And this innovation that we are very proud of, we're the only company in the world actually that has proven that we can, using silicon photonics, do co-packaged optics, which are the 8 tiles that you see here. It's about 6.4 terabit per second each tile, and these are modular tiles. You actually now can have a fully integrated switch together between Juniper and Broadcom, where you take 400 gig optics. You can take actually 128 of these modules of 400 gig optics and integrate them all into what you're looking at in here. And as a result of this, you actually can see at the transceiver level, at the 400 gig optics level, of course this is applicable to 800 gig as you plug it in here, 70%, 70, power reduction. Now we are actually changing the game collectively. And as a result of this, not only we get the power savings, which is massive. We're not talking 5, 10, 20%. We're talking 70%. We are actually talking about space saving. And ultimately, cost matters. This is going to be over 40% cost savings for our customers.
This is an amazing innovation, and we are proud to be the first company
Yes.
to work with you to come bring this to the market. So very excited about power efficiency. But power in the systems is one thing, but we're also working on turning off parts of the system, right? Turning off power, ports, optics, sometimes ASICs, sometimes entire systems, sometimes parts of the network. We got to think in terms of how do we save the planet in this regard, right? So, but it all starts with something like this. This innovation is something I'm super excited about, and we're going to continue the collaboration. Very exciting times for us ahead. Thank you for joining us, Charlie.
Thank you.
Excellent. Thanks, Manoj and Charlie. Some great insights on use cases and the future tech trends on innovation, especially around power. Bob, power is huge.
Yeah, absolutely. We're going to need organizations to drive much greater efficiency if we're going to be able to have sustainable data centers for AI use cases.
And all the improvements are critical to have power. Coming up next, Mansoor Karam, GVP of Products and Data Center at Juniper, sits down with Broadcom's Ram Velaga and Ray Moda of ACG Research to dig deeper into the economics and the performance of Ethernet networking for AI.
Yeah, I'm looking forward to this one. I want to see if they think this will become Ethernet will become the de facto standard for all these AI clusters.
Before we dive in, tell us a bit about yourself, guys. Let's start with you, Ram.
My name is Ram Velaga. I run the switching and routing Ethernet business at Broadcom. And the last couple of years, I've really been fighting the Ethernet versus InfiniBand battle.
Excellent. Ray?
I'm Ray Moda. I'm CEO and principal analyst for ACG, and we focus primarily on the service provider space and the large enterprise, doing a lot of work on research, but economic modeling as well. Ethernet, it's been a hot topic lately.
It has, indeed. So let's jump right in. Ram, I'm going to start with you. At your most recent AI virtual event, you talked about InfiniBand versus Ethernet, but I think you really set the context properly by talking about the importance of the network, especially in today's AI clusters and AI workloads and AI applications. Can you tell us a bit about that?
Yeah, sure. If you think about AI, right, the first thing you have to think about is it's a distributed computing problem. And what I mean by a distributed computing problem is you cannot take an AI workload and run it on one GPU, no matter how big your GPU is. Somebody today can come and say they have the fastest GPU. 2 years from now, they can come and say they have something that's even faster. But the reality is any particular GPU or accelerator is only as big as what a TSMC can build or advanced packaging that you could do or the fastest HBM you can put on. But really what you need for a machine learning or an AI workload is many tens of thousands of these GPUs all acting together as if they're one very, very large computer, right? To do that, you really have all of these to be tied together and all of these have to be networked together.
Right.
And that's what we mean by, this is a distributed computing problem. When you have a distributed computing problem, the network is what ties all of this together. And the network becomes the computer.
Right.
Because anyone can build the fastest GPU, but if they cannot tie all of these GPUs together to act as if they're one large piece of single computer, the whole thing falls apart. And that's what we mean by the network is the computer. And if network is the computer and you want to build the best network that's out there, there's nothing like Ethernet.
There was a finding from Meta, which I thought was really insightful that you highlighted in your talk. Can you tell us what that finding was about how the network is critical for making sure that these GPUs don't stay idle?
So I don't know if you've seen this presentation, which was presented by Meta, I believe about a couple of years ago at the OCP. And what they showed is different workloads that they had, different kinds of recommendation models that they had, and how much time was spent in the network, the traffic going back and forth between these GPUs. And it varied anywhere from 20% to almost 57%.
Right.
What it means is there is that much amount of time, somewhere between 20 to 50, almost 60% of the time, the GPUs are sitting idle, waiting for the traffic to be shuffled between these different GPUs, right? Now, so think about it. Typically, these GPUs probably sell between $20,000 to $30,000, depending on how favorite a customer you are
Sometimes
of the
more.
vendor.
Sometimes more, a lot more.
Now, and then you take those and you're now putting together 100,000 of this. You do the math. That's anywhere between $2 to $3+ billion in GPUs.
Right.
And if these things are sitting idle, that's a pretty expensive
When
affair.
we talk about $1 billion, right? Like
No,
50%.
Yeah, so if you say 50% of the time you're sitting idle, you're sitting, about $1.5 billion sitting idle there.
Yeah. And in that same study, Meta actually, they built two different clusters, one with Ethernet, and we can talk about now Ethernet versus InfiniBand.
Look, I think, 2 years ago, if you talk to anybody, they said, if you're building a GPU, cluster, AI, machine learning, nothing other than InfiniBand will
Right,
work.
I remember.
Yeah. Right? It was everywhere you went, it's like, oh, if it's not InfiniBand, this is not going to work. And I was sitting there scratching my head saying, that's not true, right? Today, when you look at it, top seven out of the top 8 largest clusters in the world are built based on Ethernet.
Yep.
There is one last remaining one that's built on, InfiniBand, but my take is, in a year and a half from now, that will also be based on Ethernet. Okay, so what's happened over this 2-year period is, initially when you get a solution that's kind of all purpose-built by the vendor and that says, okay, look, you cannot touch any of this. You've got the GPU, you've got the NIC, you've got these cables, and you've got the switches, and all of this is pre-engineered by us. If you touch it, the thing is not going to work. There is a lot of fear, uncertainty, and doubt based on which the customers who are in a rush to deploy these systems will just take it as somebody is giving it to them, right? But then as customers start to deploy them, they'll start to find out, look, operationally, InfiniBand is very different than Ethernet. Number two, it has a tendency to just literally, break down quite a bit more than just Ethernet has been built for, because Ethernet is built under the notion that it is going to be very scalable, reliable, and so on and so forth. So customers have gone through these experiences and said, look, I have to actually benchmark InfiniBand versus Ethernet to see if it is worth this hassle of maintaining this InfiniBand, which is very, fragile. Right? And they started to test, and Meta put out this paper. They did over 24,000 plus GPUs, and they tested them both, and they found out Ethernet was pretty good. It was actually in many cases very comparable performance to InfiniBand, but with the operational ease and reliability that you expect out of Ethernet. So there's more and more benchmarks that have been done across the industry, and that's why the industry has moved on to Ethernet.
Yeah, and I think there's history here too. In the past, I mentioned when I was a former CTO, I loved ATM technology because you could slice and dice the data. We had triple play back then, but I remember designing trading floors and stuff like that. And my boss came over and said, I want you to try these broker workstations with Ethernet. And I'm like, Ethernet? Are you kidding me? We have ATM
and we make a lot
anywhere
of money.
like that, right? But then our CFO came in, hey, it's $1,200 a NIC car for an ATM 25 meg, and it's $69 for 100 meg.
At price.
Right. And I was like, so I learned the economics part of network design, but initially I was concerned about the architecture of Ethernet, but it just kept getting better speeds and that efficiency. So I learned early on never to bet against Ethernet from that perspective.
Right. The ubiquity of Ethernet.
Yeah, the ubiquity
makes
is there.
So from an economic standpoint, maybe do you want to comment a bit more? I know that you did a study recently, right, of the economics of Ethernet.
And for those who don't know, what we do is we have a software platform that's kind of like a digital twin, but it does economic simulation modeling of whatever architecture versus any architecture, any technology versus any technology or any use case or application for that perspective. So what we did in this particular case was we model Ethernet against InfiniBand, and then we use a similar architecture where we use spine leaf technologies, and we had a server environment where we had the DGX8, I think the H100s, and from that perspective, we had the server environment, but then we had a compute network that we had InfiniBand, but then we had, in this case, the Juniper, the QFX switches from that. And then the interconnections range between 400 to 800 gig. And honestly, some of the findings from a CapEx perspective is about 55%, because even the ports on InfiniBand itself are twice as expensive as an Ethernet
so
port.
50% cheaper for Ethernet compared to InfiniBand.
Yes, 50% cheaper.
So less than half the cost.
And then when we looked at some of the other parts from the switching costs, then we looked at the equipment costs, which a lot of people forget, cables, optics, that adds up over time, and there's different requirements. And then the second part is the OpEx.
Right.
How much does it cost to manage this environment? And this is where we model, intent-based automation with Abstract to say, how do we simplify? So the overall TCO came out to about 56% savings over a 3-year time frame right now.
Wow. So we're talking about same performance, better reliability, and more than half the cost. But then to get to performance, I think that another also critical factor is management, right? Debuggability, observability, right? And the ecosystem of tools, right? Knowing what's going wrong in the cluster or fine-tuning a cluster to make sure that the parameters are all set properly from a networking standpoint is also very important. Knowing what's going on the on the link, on the wire is important. Right. And for Ethernet, there are hundreds and thousands of tools out there. Of course, we built one, Apstra, now part of Juniper, which works across all types of vendors. But there are many, many such tools on the market. Yeah. I suspect that that's also a factor compared to InfiniBand. I don't know how many tools there are to go and debug or provide observability into InfiniBand. I suspect that was a factor in your study.
That was a major factor. I mean, we focus mostly on tangible benefits, but there's a lot of intangible benefits associated with it, where when there's only one vendor, you're at the mercy of their timeline and their priorities, not yours. Right? So that's a challenge, right? The other part is the number of skill sets that are available out there to be able to support something that's set up this way and stuff like that. Where if you look at, I talked about just the cost of the equipment, look at the cost of the skill sets that you have to acquire. You normally, when you interview an engineer, you don't ask if they have Ethernet skills, right? So I think those are the intangibles that people aren't thinking about. How much is it to the skill sets to maintain? Because that adds up to operational costs. And more importantly, I'm more concerned about business continuity. Because realize we're talking about AI, but some of these models could be used for high performance computing or whatever parallel processing that requires that type of environment and stuff like that. So there's a variety of use cases on top of AI for that.
Yeah, I mean, I can imagine that an organization has multiple networks, and the more commonality there are in these networks, the better in terms of leveraging the workforce, the expertise. Also, there are some security aspects, right, Ram?
Yeah, so let's talk about security, right? So for example, now specifically when you think about AI coming into the enterprises, what do enterprises have that's really differentiated? That is their own customer data, their own analytics, how their whole business runs. And a lot of that is very proprietary. And some of it is so fundamental that they're not necessarily maybe going to feel very comfortable putting it outside their own premise. Now, so they start to build their, private AI cloud, so to say. When they start building it, what needs to happen is there's a lot of data that goes back and forth between what is stored in their cold storage, active storage, and into these GPUs, doing the data analysis, crunching out some, coefficients, and then pushing it out. So what this means is it has to come into the natural security policies you have already inside your enterprise and how things are being stored, secured, who do you give access to what, so on and so forth. So if you build something with something like InfiniBand, which doesn't have this notion of access controls, security, and so on and so forth, you're going to be building completely different islands. And the whole idea of building something that's private, into your enterprise and moving data back and forth is not going to work.
Right.
Which is where kind of having everything on Ethernet, one common fabric, one common set of policies, one common set of access controls, right? Just makes all of this so much more easy.
I was going to say, I'm actually glad you brought that up because not enough people are talking about the security aspects of it, because I always say security is as strong as your weakest link, right? And then having the more distributed you have security, the harder it is to manage and more opportunities for penetration. And you don't want to have these dead pockets where people don't have understanding of what's going on in that area. So I always say no security, no business.
Excellent. We've said that Ethernet provides similar performance than InfiniBand. Maybe tell us about UEC. There is an effort, right? I think it's about improving the scalability of RDMA specifically, right? Yeah. Do you want to tell us maybe a bit about, the purpose for UEC and how it's going to scale Ethernet to even further?
So while Ethernet today does everything that InfiniBand does, toe-to-toe, can go in, better performance, much higher reliability, less than half the cost, we're all kind of thinking ahead about how do you improve RDMA, not Ethernet, but how do you improve RDMA? And that's where UEC has come up with a bunch of improvements to RDMA that allow it to do multipathing. So you don't assume there's just one path between point A and point B, that there's multiple paths. Then you have efficient, retransmits, which is if packet 4 got dropped, but 5, 6, and 7 got transmitted, we will go back and only retransmit packet 4 rather than transmitting 5, 6, and 7. So it's built under the assumption that your underlying fabric might actually fail, rather than InfiniBand and RDMA that said underlying fabric will not fail, right? So you build resiliency, knowing failures will happen. Otherwise, it's like, hey, building in, a skyscraper in San Francisco saying there will be no earthquake, right? That's a ridiculous assumption to make. Assume there's earthquakes and retrofit the buildings, and that's what is
Excellent. There is going to be a large ecosystem around it and multiple topology options, right? Like where you can involve the NIC, or you may just work within the confines of the switches, correct?
Exactly.
Yeah. Excellent. All right, gentlemen, that was insightful and lots of fun. Thank you very much.
Really great discussion, especially the part about Ethernet being able to deliver some performance as strong as InfiniBand with more reliability and half the cost. Bob, you're the networking guy. You go deep on this. InfiniBand, Ethernet, performance, lower cost, higher performance. I mean, they got the magic formula.
Yeah, absolutely. And I think it's really hard to bet against Ethernet, right? And it's also interesting to note, they talked about the fact that Ethernet's now deployed at 7 of the 8 largest GPU clusters today.
I love it. I love the Ethernet InfiniBand conversation. Now let's get back to Praveen, who's going to lead a discussion featuring PayPal, Deutsche Bahn, and Juniper's system integrated partner E+, to hear firsthand from a couple of organizations that have some real experience deploying AI clusters. Praveen?
First, I want to extend my heartfelt gratitude for taking the time out of your busy schedule to join us today. I will start with Sudheesh, if you can introduce yourself.
I'm Sudheesh, Vice President of Innovation and Emerging Technologies at E+. We are a system integrator and a reseller, and our goal or our mission is to solve real-world business problems through innovative AI solutions, right? Our comprehensive services include AI professional services, AI consulting, AI advanced support services, as well as we have a AI dev team which does AI ML research and build custom use cases for our customers.
Excellent. Thank you, Sudheesh. Thank you. Sai, if you can introduce yourself.
Thank you, Praveen, for having me here. At PayPal, I manage, operate global infrastructure platforms. PayPal operates in 200 different countries. We have 430 million consumers and merchants in the platform. And we process $1.4 trillion in a year.
Wow.
This requires global infrastructure presence to serve our customers and provide PayPal experiences to everybody. So this year's focus has been AI and security, as well as providing deployments of these applications across the board. That includes hybrid multi-cloud.
Very good. Thank you, Sai. Alex, if you can introduce yourself, please, next.
Thank you that I can part here of the session. My name is Alexander Heine. I'm part of the Digital Rail Germany, so-called Digitale Schiene Deutschland, of the company Deutsche Bahn. And we are responsible for providing the rail infrastructure in complete Germany, so 34,000 kilometers of track. And for this, I'm the head of IT platforms and services and the necessary data platforms to research and operate at the end AI-based traffic, for example, to use it for capacity traffic management or for fully automated driving of trains.
Sudheesh, as a system integrator, what are the use cases you are seeing across different verticals?
It's interesting to see how customers are bringing those problems to solve with AI has been very rapid for the past 12 months, as we all know, right? So from a healthcare perspective, it's mostly medical imaging analysis, nurse scheduling, or some other use cases we hear. From a finance perspective, fraud detection, sentiment analysis, portfolio management, or some of the use cases we see from a finance vertical. Manufacturing, very interesting, mostly computer vision use cases, building predictive maintenance, as well as for customer service, or some other use cases which we see from manufacturing side. We also see a lot from legal. There is a lot of interest from legal use cases, which is mostly around, they have a lot of manual stuff which they do. So it's mostly around legal research, contract management lifecycle, and whatnot. And from another vertical, which we are also seeing good amount of interest, is around transportation and logistics, where they are looking at mostly around predictive maintenance, supply chain optimization, as well as tracking their shipping and whatnot, right? So that's another area. The last one, which we have few inquiries, is around education, right? For personal tutoring, automated grading assistance, and optimization of their admission process and whatnot. So this is a
broad spectrum.
spectrum.
Fortunately, we have 2 customers today which exactly fit the profile of verticals where you are seeing the AI explosion. Let me start with you, Sai. If you can share, how are you using AI in your infrastructure?
At PayPal, we've been using AI/ML for a while now. It powers our risk and fraud protection, with generative AI being additional capabilities that we are building. The best way for me to explain the use cases and how they fit in the profile, this is a security and data strategy at the center of everything what we do. Right, so you can plot a 4-dimensional graph if you can, quadrants. The y-axis being internal and external, x-axis being helper functions and actionable things. You can put all your use cases into these 4 quadrants.
Oh, I like it. It's
internal
unique.
and helper, internal actionable, external helper functions, external actionable. Based on your maturity model of data strategy and security strategy, you can move around these use cases in solving it, right? So some of the examples of internal and external, internal and helper, Copilot use cases, right? And internal and actionable is something like, it's a very innovative way we are leveraging it. Incident response and incident handling, how you can reduce mean time to recovery. And same goes by external helper. We recently introduced PayPal Assist chatbot. If you accessing PayPal helper page, you can chat with the AI bot powered by these generative AI engines and particularly fine-tuned models behind the scenes. And then the last, which is more provocative as well as somewhat you have to have a maturity model to address external and actionable. That's you are taking action based on your customer asking specific activities that requires that utmost care. And once you are ready with all the security aspects of it, you can solve, right? So that's the way how I can describe all the use cases in the universe, particularly this AI bandwagon.
Very good. Thank you. Thank you, Sai. Over to you, Alex. What are you seeing in the transportation industry?
We use, for example, AI for capacity traffic management optimization. So recalculating of the best way that a train can go with all restrictions, for example, weather incidents or different kinds of requirements of a track. Not every train can go to the special tracks. And this has a very big data amount is needed to make here an AI prediction. For this use case, for example, we use reinforcement learning to find new ways to make to use the capacity on the track much more better. And second use case is that we want to go from now we developing GOA2 systems, grade of automation to it means that we have train drivers that supervise the train. The train brakes and drives by its own. But and train driver must take over the control every time. And our main vision is to have here a fully automated driving train that detects the environment by themselves and react in the right way. So this is a classical, the GOA4 approach that we try to implement here to use it to use automated train operating trains in shunting areas, for example, to building new trains, to go to distances that normally are not so attractive for our employees to go.
So moving on to our next topic, all of us have choices, right? Either we can build our own data center, consume GPU as a service from the cloud, or maybe a hybrid approach. Sai Krishna, I want to start with you. What are you thinking in your organization?
At PayPal, we follow hybrid multi-cloud deployment. That is primarily based on our data strategy. For example, the data which is required for research and development, that is currently hosted on-premise. So we have workloads that are related to this research and development, which are residing on-premise. And where it comes to the inference related, those are deployed in cloud. So we kind of like building this infrastructure to support all different kind of use cases today.
Alex, what is your strategy? And if you also can share, why did you choose that strategy with respect to on-prem or cloud or hybrid?
In Deutsche Bahn, we have the strategy that everything goes in the cloud. Yeah, this is the main strategy, that we use AI use cases and all the functionality with our preferred partners there. But we have very high intensive data parts. Yeah, so this means that our heavy data, we must proceed or process this data very close to the data sources, and this is the reason why we also build up own AI data centers to pre-process the data very close to the track, but also to have central processing areas where we consolidate all this together and have big data storages together with the AI fabric at the end. And one driver is also the data sovereignty that we want to implement here. So we generating new data. We want to exchange this openly with other industries to reinvent or to find new industries also that help us to develop here a new railway system at the end. And this was the reason that we built up own data centers. So we following here a hybrid approach. It's driven by total cost of ownership. Yeah, it's also driven by the data management, data use cases that we have here in mind.
Oh, thank you. So to summarize, choice of building your on-prem data center versus consuming it from the cloud depends on your latency requirement, data privacy, and also, as Alex said, maybe also the volume of the data you are consuming.
Where is your data?
Where is your data? Maybe
Right.
where is your data? So
Right.
thank you.
Yeah.
So that brings to me to the next topic with respect to how do you operationalize these on-prem data centers? These are not easy, right? As Sudhish, you were saying, the power, cooling, and aspects of hosting these data centers is not easy. Maybe I'll start with you, Sudhish, if you can share your thoughts since you are building some of these data centers for your customers. What are you doing and how a company like Juniper can help?
Sure. So what we are, when you look at this whole stack, right, like your DC stack is there, your compute network storage is there. Then on top of that, you have your operating tools, operational tools like monitoring tools and whatnot. And here you also have this whole concept of ML stack, which is that PyTorch and whatnot. And above that, you have MLOps framework. It's a whole, like you said, it's not that easy to manage, right? So, but the thing is, there are a lot of tools which is evolved and matured so that it's making easier for customers to build it like an AI private cloud and consume it, okay? Again, we are going back to the previous discussion where we were talking about, how do you manage the power and cooling? What is your skill set do you have internally? Always look at the cost analysis. But as you are looking at the cloud and the GPU demand and how much it's costing to run in cloud, it for variety of reasons, for variety of workload, like large distributed training and where your data is, data privacy, looking at all those, customers want to run it, and where there are providers like us who can help them successfully not only build, also support them if that is needed.
Yeah. Can you also elaborate on how tools like Apstra, for example, and how we are auto-tuning the congestion has helped your customers?
Oh, this is it's a 1 hour topic if you want to get into that, right? But it's from a Juniper's point, I think in terms of not only building that Ethernet lossless fabric, as well as you have the whole, PFC, ETS, and the advanced features, forwarding features as well within the fabric. And on top of that, you also have this Apstra, which is like a multi-vendor sort of orchestration, automation, telemetry, awesome tool, right? So this absolutely helps the customer, removes a lot of operational pain to automate and whatnot. Great question you asked. I didn't point that, but it's fantastic that Juniper has this whole fabric, AI fabric. On top of that, you have the operational telemetry and visibility you provide through Apstra is just phenomenal.
Yeah.
Thank you.
No, I
You
wanted to
add
add one
something,
more.
yep.
Yes. Efficiency is one of the key factor that you wanted to pay attention. All workloads doesn't need even a full GPU.
Makes sense.
Particularly the Gen AI related workloads.
Everybody doesn't need a Ferrari.
Exactly.
Yeah. Inference mostly you don't need that big.
So the efficiency play a huge role, and particularly not only utilization aspects of it, and the power, everything goes along with it, right? So what we are looking at is fractioning, particularly the smaller use cases, AI, ML. You don't need that heavy duty full GPU. Leverage the fractioning technologies, and that map it to your network fabric, which will bring out the connectivity, easiness. This is somewhat in the infancy, how fractioning as well as connecting to the network fabric. And Praveen, I really look forward to
innovating together
with
on
Juniper,
that journey. Yeah.
Right. So this is one of the area which we are paying very deep attention, and infrastructure has to be ready for another 18 months, 24 months ahead.
Yeah.
Right? So we are looking forward.
Yeah. Thank you. Thank you, Sai Krishna. Maybe let me ask Alex, any final thoughts or word of advice for the people who are building their on-prem data center for the AI clusters? What challenges or any advice from your learnings, what they can do, what they should not be doing, or what should they do or should not be doing?
Yeah, I think my lessons learned was that I need the data center where the energy is. Yeah, so AI workloads are so heavy energy consumption that it is very hard. Yeah, so and also one big part is the connection to the network. Yeah, so to the backbone network. Yeah, to get the data inside of the data center. Yeah, to bring the data to the nodes, bring this back to the processing units. I think the network is the key, as a backbone network, also the communication to in our case, to the field elements outside, to the edge cloud components, to bring all this together is quite important. And this has something to do with data management. So when I would start now, I would say, define before I start a quite proper data management that is stable enough to survive also 5, 10, 20 years, to survive also the data that I must handle at the end, that I must transfer everywhere, and to implement a data lifecycle that allows us also not to store everything, but to store the right data at the end.
Thank you.
So,
Subhash.
So I just want to add one thing, right? When you are looking at building this AI on-prem data center, depending on what workload you're going to run, make sure you have a, like I said, space, cooling, all that should be taken care. And also you partner with the right provider to ensure that you have a end-to-end stack that can build and automate. And observability is another key area which you want to look at, where you can monitor different aspects of things. When it breaks, you should be alerted proactively and have AI on top of that.
Yeah, to your point, we have our AI lab in Juniper, which you have seen.
Yep.
We are constantly seeing our GPUs are underutilized because sometimes something breaks, something doesn't work.
Exactly. This is why Apstra and your whole stack absolutely will help customers. As well as I've seen your lab, fantastic lab. We have bought customers there. It's a big environment to run any sort of large training data LLMs and validate some stuff. I've done that. It's a fantastic lab what they have.
Thank you, Sudhish.
Yep.
With that,
great partnering with Juniper. My final thoughts are, get your data strategy right, get your security strategy right, and look at 18 to 24 months ahead. Where is your AI workloads are evolving? What is your infrastructure strategy to support that particular growth? Right? So have this clarity, it will be good.
Thank you. First of all, I want to thank you all for being a Juniper customer. Thank you for putting your trust in us, and we are here to deliver. And this is a new journey. All of us are learning, but we are on for this game. Thank you again for joining.
Thank you.
Thank you.
Next, we'll hand things over to Rakesh Kumar, Senior Engineering Leader at Juniper, to talk to two industry leaders and pioneers about the best practices when operating AI clusters. Rakesh?
Today, we are going to be discussing AI cluster technology and how it can unlock the next stage of AI adoption through powerful collaboration that democratize AI infrastructure by driving down the cost and accelerating innovation. Thank you, Adi and David, coming in today. David, tell us a little bit about you.
Yeah, it's a pleasure to be here. My name is David Cantor. I'm one of the founders and the executive director of ML Commons. We're a nonprofit and industry consortium bringing together industry, academia, and many different constituencies to make AI better for everyone, to make it faster, more efficient, and safer.
That's very interesting. And how about you, Adi?
Yeah, hey, I'm Adi Gangedi. I'm a production network engineer at Meta, and I help build and scale RDMA training and inference clusters at Meta. Meta has been building training clusters for a few years now, and I've been involved in several aspects of these clusters all the way from day one. Today, we have a large team managing these clusters, so it gives me an opportunity to focus on AI training performance, specifically from a communications and network standpoint.
Very interesting background. And David, tell us a little bit about your ML Commons, what you do, and what kind of things you have been thinking about.
Yeah, so ML Commons really got started with the MLPerf benchmarks, which is part of what's bringing us all together today. And it was sort of founded in the early days of machine learning, and we didn't have good standard ways of measuring performance. And so, we got the whole community together. We built some standard measures for AI training. So that became MLPerf training. And then over time, we've really branched out into inference, whether it's in the data center, on IoT devices, on smartphones. And really here, the goal is how do we bring together researchers, production engineers, sales, marketing, everyone on making AI more capable. And so if you're a customer, MLPerf is a great tool to figure out what should you be buying to help validate a vendor's claims. And one of the things that I'm really excited about that the team has done recently is, first of all, we've added a lot of Gen AI benchmarks, but then we also added power measurement so that you can see whether it's data center, inference, or training of these large-scale models, how much power and energy are you using? But again, it's all in service of bringing this information together and helping bring together, buyers, sellers, researchers, advanced developers, and kind of driving the community forward. And we've seen in the 5 years that we've been around, we were able to get, something like 50x better performance, which is, way faster than what we would expect. So.
Thank you, David. That is very interesting, and it's amazing the kind of work you're doing. Yeah. So Adi, tell us about that Meta and how you have been working with ML Commons.
Yeah, actually, interestingly enough, Meta was one of the founding members and has been there all along the journey of ML Commons. More recently, Meta's Llama 2, for example, actually is one of the inference and fine-tuning benchmarks as well. And in general, I think benchmarking and the work that David and ML Commons team is doing is really, really important. Because with benchmarks, you can really understand how ML models stress infrastructure or what tasks they're able to do, and you're able to reproduce them and repeat them. And if you cannot reproduce something, then it's really, really hard to improve it or to make it more reliable or so, right? So benchmarking is a very, very fundamental aspect of, what helps these, scale these clusters, things like that. And we are really committed to actually engage in ML Commons. We are active members, for example, of the Chakra work group that is focused on improving communications performance and representing the communication primitives of the AI ML models.
No, so Adi, this is really interesting, the kind of work your organization is doing and leading the effort in making this solution very scalable. This is very helpful. So David, tell me about what do you think is the next coming for ML Commons, and what do you think the kind of things you have in mind?
Yeah, so again, one of the things we spend a lot of time doing is working with, companies that are really on the cutting edge, Meta, Microsoft, Google's, all of our members help to contribute. And so one of the things that I've certainly seen is, of course, there's the explosive rise of large language models, image generators, other forms of even more computationally demanding machine learning, where we need larger and larger systems to satisfy them. And sort of for the first time ever, we're starting to see people talk about inference using the network, right? And like for a long time, when we started out, when I led MLPerf inference, it was just a single node thing. But now these models are so big, we may not be able to do that anymore. And so, that's sort of one trend I see. The other thing is from an organizational standpoint, we're starting to look at things like end-to-end inference. So how do you incorporate things like RAG or other augmentation techniques with LLMs and other things? So we've seen this rise in vector databases. How do we think about that? And then there's a lot of cleverness, things like mixture of experts that starts to say, hey, let's maybe de-emphasize just straight compute, and let's think about a blend of compute and networking and control that gets us to a different balance. So, those are some of the things I'm seeing, as well as, sort of a renewed push around energy efficiency, especially around next generation data centers.
David, that was very interesting background you gave, and you explained to our audience how networks play a very critical role in building a large scale infrastructure for large language model and for inference and training. So this is very important for Juniper too, because Juniper is also in the forefront of building networking product, and we want to make sure our products really work well for these kind of use cases. And Adi, I would like to understand from you what kind of things you have been doing, which you are basically bringing to the forefront to all this networking technology. You want to share your perspective?
Yeah, definitely. I think the thing that I want to echo is that network and communications are very, very integral part of being able to run these large models or DLRM models, all of these models in like a stable fashion, but also in terms of extracting the most amount of performance out of these models and out of these clusters. So the communications stack is like really the key. And there are several things I think we are doing in terms of moving the needle here. Definitely, one of the challenges that we're trying to solve is that the DLRM models, the ranking models, the kind of traffic patterns that they produce, and the generative AI large language models, especially those ones with training, they produce different traffic patterns, and the traffic patterns produced by distributed inference that, like David just mentioned, are also slightly different. So, can we build fungible clusters for all of these use cases? Or in some cases, do we have to build specialized clusters for some of these applications, right? So that's something that we are actively looking into and trying to solve. And as we talked about Gen AI models, as those models scale to a very large scale, reliability becomes like very, very important. Any systematic unreliabilities in the network, or so needs to be like really, really addressed. And even after you address all of those concerns, just by the fact that you have so many links, so many switches, so many GPUs, training, it gets really tricky in terms of being able to avoid interruptions to the jobs. So if you cannot avoid it, if there is an interruption, how do we very quickly realize where the failure is and isolate it? How do we kind of get these jobs to start really fast? So if there are some initial network synchronizations that they need to do before they go on the fast path and continue training, how do we kind of reduce that synchronization time in the beginning? So those are all the things that are like very, very important from a reliability standpoint. But there are a lot of things also that we are doing in terms of making these clusters more performant. And for example, network load balancing for our Rocky clusters and our InfiniBand clusters is like fairly important, because if you cannot load balance all the traffic, from the collective communication patterns produced by these ML models, then your tail latency increases. Your next training iteration is running slower, right? So you need to manage congestion, you need to manage load balancing, you need to customize the scheduling of some of these applications so that optimal infrastructure is allocated to these large models to make them performant. But yes, I think overall networking and communications are absolutely in the forefront of enabling all of these revolutions around generative AI.
This is amazing, Adi, what you told about. And we have some experience when building these AI labs, and we trained some of these large language model. And some of the things we brought out, Juniper saw all those things in our lab too. So I'm glad you are leading this effort and educating our audience in what kind of challenge and how to overcome those challenges. Thank you very much, Adi and David, for joining us today. And thank you, audience, for watching us today. Thank you.
Thanks, Rakesh. Some great tips there. Let's shift gears a bit to have a discussion with Praveen and A.E. Natarajan to discuss the AI Juniper announcement with more detail. Okay, we're back. I'm John Furrier with theCUBE, with Bob Liberté with theCUBE Research. We had great sessions so far. Now we're back with Praveen, who helped kick us off, and we're here with A.E. Natarajan from Juniper. Gents, how do you think of this program so far? What do you think of the show?
It went very well. I hope viewers are able to learn something from today's session.
Great content, amazing speakers. A.E., why don't you introduce yourself to the audience and what you do at Juniper?
Thank you, John and Bob, and it's a pleasure to be here along with Praveen and the rest of you. I'm A.E. Natarajan, Executive Vice President at Juniper, responsible for WAN products, silicon, a whole bunch of things, and AI is the most exciting thing that I can actually talk about. Really, really a pleasure to be here.
Praveen, I want to get into the AI networking and AI native networking specifically. You launched AI native networking earlier this year. Can you give us an update and share more about what that's about?
Yeah, so first, let me reiterate, the AI native networking means when the networking products are built from ground up with AI as the core component, right? It's not an afterthought. It consists of two parts, AI for networking and networking for AI. In AI for networking, if you are familiar with our MIST technology, where AI ops was the key focus, we applied the same technology to our data center so that we can simplify the operations. On the other hand, from networking for AI, again, the focus is end-to-end simplification, right? End-to-end operational simplification. And how we achieve that? Today, we are coining another term called Ops for AI, which consists of intent-based networking, AI-optimized Ethernet, as well as AI ops. This is AI ops now applied to networking for AI. Ultimately, what we want to achieve, the utilization, the best utilization from the network, the best performance from the network, at the same time with ease of management.
Praveen, the Ops for AI announcement looks really interesting. Can you share specifically how this new announcement, Ops for AI, complements your existing portfolio?
Yeah, John, first of all, let me just clarify, right? Ops for AI, we have built a lab, and we are calling it Ops for AI Lab, where customers are coming in, training their own model, and figuring out that this is the performance and this is what they want to build on-prem when they go back. So also I want to tell you that when you build these clusters, there are, let's call it 3 types of network. There's a network where how do you go and access this cluster? There's a network which is called storage network, where GPUs are communicating to storage over this network. And then there is a backend network. The backend network is where GPUs are talking to each other. So 3 types of networks. Sometimes you hear the words front end and back end, but let's say predominantly there are 3 types of networks. Maybe I'll turn to AE to talk about how we have the breadth of portfolio to cover all this 3 types of networks.
Absolutely, Praveen. I'm very excited to actually talk about this because here at Juniper, we build our products with our own silicon and with commodity silicon, which gives us the flexibility to actually customize our products that can be form fit for each and every variation that we can think about, right? That is interesting. The second part which we wanted to talk about is the QFX products, which are the core center of the data center, where you actually build all the GPU clusters, connect them across with a QFX cluster in the data center. Now, your GPU clusters are getting bigger and bigger, and you have to interconnect them now because of whether it's power, thermal, or space capacity, whatever reasons, you have to go past one building or one data center and actually interconnect them. We call this data center interconnect. And we have some exciting products that actually cater to the data center interconnect, which is our PTX portfolio of products. I'm proud to stand up here because this is the core of how we innovate here at Juniper. We were the first to release 200, 400 gig, and right now we're the first to release 800 gig. 800 gig, and this is amazing because this is an innovation where bandwidth hungry, data flow hungry, AI clusters are going to actually use that most effectively.
It's hard to mention connectivity without talking about secure connectivity. So AE, I wonder if you could address what Juniper's doing to secure these back-end networks.
Oh, thank you. Every time we talk to customers, one of the most precious things that they have is data. They want to protect their intellectual property. They want to protect their data, which is the reason when they train these models, they want to host it in a secure environment so they can train these models and make sure that these models are not getting hacked into, like Hugging Face and other things that have actually happened recently. We here at Juniper, we have a way by which we build a ubiquitous security control plane. What it does is it doesn't matter whether you use Juniper's security products, which is the SRX products, either virtual or physical products. You have a unified control plane from which you dictate the security policies.
Single policy domain.
Policy domain. It actually pushes it out to the entire domain so you know you're protected, and you're protected extremely well.
Awesome, that's great. One other thing I wanted to touch upon, Praveen, I think you mentioned earlier that Ops for AI Lab. And if I remember correctly, we talked about it at the beginning. Any chance we can give the audience a sneak peek into that environment?
Absolutely. So what we can do for today, we can roll the video because we have a pre-recorded version of the lab tour. But I do want to point out, today we are announcing that you can come visit our lab, try your model, so try and buy program, try and buy. And you will be able to see what we have done with our ecosystem partners. So it's not just about a single vendor solution across all the ecosystems, running real training workloads and showcasing how we achieve performance and scale and operational simplification with Juniper products along with the ecosystem partners. With that, please roll the video.
Juniper's Ops for AI Lab is at the forefront of innovation. We have invested millions of dollars to create the networking industry's first and only AI lab to help you accelerate your AI deployment with confidence. AI infrastructure is a new frontier for most enterprises. Our fully operational, well-equipped lab and experts are here to help. We invite enterprises and partners to confidentially test models such as Llama, BERT, DLRM, or even your own models along with your data or use open source data sets. At Juniper, we value collaboration. We are excited to work closely with you and our ecosystem partners to deliver robust, high-performance, easy-to-deploy solutions. Additionally, you can leverage Juniper's validated design based on open, standard-based, and proven AI-optimized Ethernet infrastructure, interconnecting NVIDIA GPUs and backup storage for AI training and inference working. See how Apstra, our data center fabric management and automation solution, simplifies orchestration. This lab also serves as the pivotal environment for testing ML Commons submission, reinforcing our commitment to advancing AI technologies and industry standards. AI data center infrastructure doesn't have to be a mystery. At Juniper, we are committed to democratizing AI. We can guide you through designing, deploying, and operating AI infrastructure.
Wow, that's great stuff. Love that lab. This is like an excellence center. This is where you guys are doing some great work. Congratulations on that sneak peek. Got a good look at ourselves here with theCUBE Inside Edition. Thanks for doing that.
Thank you. Thank you, John. Thank you, Bob.
Thank you, John.
Guys, congratulations, 800 gig, you're feeding those starving AI workloads, good stuff, and open, love that. Congratulations.